So just to recap, when you want to have more than one function with the same name, you need to make sure that one of the arguments of the function has a different data type. Now let's see the practical use of this. So here in the main program, I'm calling this function in a few different ways. First, I'm calling the function my_max by passing two integers, 10 and 20. Next, I'm calling the same function my_max by passing two double, 10.0 and 20.0. Third, I'm again calling the function by passing two doubles. Now, based on the data type of the arguments that are passed, C++ will call the correct function. So to see which function is called, I'm also printing the type here in the function call. So within the body, first we will see if this function is called, the integer type is called, we will see max_int. If the double type of this my_max is called, we will print max_double. So let's execute this program now, and let's see what will be the maximum value after these three function calls. So the first function call passed two integers, 10 and 20. So max_int was called. The maximum value is 20. The second time we called it with 10.0 and 20.0. Now this time max_double was called and the maximum value is 20. And finally max_double was called again when we passed 10.0 and 10.1, and then the return is 10.1, which is the maximum value between 10.0 and 20.0. Now notice what happens when we call this function my_max with a double and a integer. So here I'm calling my_max with first argument being double, second argument being an integer. Now let's see if this program compiles. So this obviously did not compile because we have two overloaded functions, definition for my_max, and neither of these take one double and one integer. So in order to call this function with a double and an integer, you need to declare a new function with first argument being a double, second argument being an integer. So C++ here does not do an implicit cast from double to an integer or an implicit cast from double to a double and then call this right function. So the implicit cast does not work, and you need to either write a new prototype which is my_max, which takes a double or an integer, or you need to cast this to an integer and then call the function. Now notice this will work because now this will call the integer version of this function. Okay, so now let's comment this back, and then now let's move on to vectors. So I've written a function called introduce_vectors. So let's go to the function's definition. So previously we saw how to store a list of values within a fixed sized array. That is, we can declare an array and store a list of integers, or we can declare an array to store a list of strings. However, the size was fixed. So at compile time, we need to specify what is the number of elements that we want to store in the array with fixed sized arrays. Now, in order to store a resizable or in order to store an array which can be resized at runtime, we would want to use std::vector. So from now on, to store a list of elements, we will use vectors, and within angle brackets, we will provide the data type of the element that we want to store. So here I want to store a list of integers or an array of integers using std::vector. The name of the variable is numbers, and again we will use pair of braces to initialize this array. So the syntax is pretty much similar to the syntax of a regular array. So here I want to initialize this vector by adding 1, 4, 16, 24, 91 into the vector. So when this declaration and definition happens, the size of the array or the vector will be equal to 5. And then at runtime, I want to push two new elements to this vector. So to do this, I can use this function called push_back. What this method does is that it will take an integer and add it to the end of the vector. So when we do numbers dot push underscore back 23 will be added to the end of the vector. Then when we do numbers dot push underscore back 32 will be added to the end of the vector. So to add new elements to the vector, you can use the method push underscore back. Now similar to strings, you can use the method size to query what is the length of this vector. That is how many elements are there in the vector. Now since we had 5 elements at the beginning and we added 2 more elements, the size should be equal to 7. Now let's see how to access individual elements of this vector. With arrays, we saw that we can use this square brackets operator to access the ith element of the array. Similar to arrays, we can use the square bracket also with vectors. So the syntax remains almost the same. The only difference is instead of having a fixed value for the size of the array, we are using this method size to query the size of the vector. Again, I here access an index. So here I'm accessing the ith element of this vector and printing it using /:cout. Now a more modern way of doing this is by using this following format, wherein we will use this keyword called auto, which says that we don't care what is the type of this variable value. C++ will internally use the correct type, and the format, this format here, is used to iterate through the elements of the array. So when you write auto ampersand value colon numbers, you will iterate through every element of this vector numbers, and at each iteration, the value will hold the ith element of this array, or the ith element of the vector. So in the first iteration, value will hold the first element. In the second iteration, the value will hold the second element. Similarly, in the ith iteration, the value will hold the ith element of this vector. So now I can just write std : cout value to print the values of the array. So this is a more modern way of accessing the elements of the vector. You can use the procedure similar to what we did with fixed size arrays, but this is more slower way of writing it in C++. So this square brackets operator is much slower than using this format to access elements of the vectors. Now finally, this function will call another function by passing this vector as an argument. So I'm calling this function sum by passing vectors as argument now. Now let's check what is the definition of this function. Now notice the argument here is a const reference. So here the name of this local variable is numbers. Its type is std : vector of int, and it's a const reference. So this was important. The const qualifier here says that this local variable numbers is constant. That is, it is only used to read and it cannot be overwritten. So we can only read the elements of this vector, we cannot change it. The second here, the important thing here is that it's a reference. That is, we are not passing this vector by value, we are passing it by a reference. So by passing it as a reference, we are not allocating any new memory when we do this function call, and we will also not copy from one vector to another vector. So suppose this was not a function call by reference, it was a function call by value. Now a local variable numbers needs to be allocated when the function call happens. The size of the local variable will be equal to the size of the passed vector, and each element of the passed vector will now be copied to this local variable numbers at the time the function call happens. All this happens implicitly in C++, but this additional overhead will cause your function to run slower. So whenever you are passing an inbuilt template like vector, map, list, or any other resizable container in C++, make sure you pass it with a reference so that you will not have this additional overhead of allocation, copy, and deallocation. And in order to make sure that this variable numbers is not accidentally modified within the function call, declare it as a constant using the constant qualifier.